Good afternoon, Miss Barber here. This lesson is titled Volumes by Cylindrical Shells. In this section, we again deal with solids of revolution. In some cases, the washer or disk method is inconvenient or just not feasible. Before we can give this method, we need to review how to compute the volume of a cylindrical shell. Let's begin with reviewing the formula for a cylinder. That volume formula is pi r squared h, where r is the radius of the cylinder and h is the height of the cylinder. Consider the picture of the shell given. We have r2 as the outer radius length, r1 as the inner radius length, and h is the height. Let's define r asterisk as the average of the two radii, that is r sub 2 plus r sub 1 divided by 2, and let's define delta r as the difference of those two radius distances, so r sub 2 minus r sub 1. The volume of the shell is the difference of the volume of the outer cylinder, which we'll call v sub 2, and the inner cylinder, which we will call v sub 1. We'll write v equals v sub 2, the volume of the outer, minus v sub 1, the volume of the inner cylinder. Let's write the formulas for those. That'll give us pi r sub 2 squared h, the volume of the cylinder of the outer, minus pi r sub 1 squared h, which is the volume of the inner cylinder. We'll proceed with some algebra. We're going to factor out the pi and the h, which will lead us to pi, and then in parentheses, r sub 2 squared minus r sub 1 squared times h. Note that r sub 2 squared minus r sub 1 squared is a difference of squares, so let's factor that out. That'll take us to pi times r sub 1 plus r sub 2 times r sub 2 minus r sub 1 h. To simplify, we're going to multiply by a factor of 1, which we will represent as 2 over 2. That is, we'll have 2 pi times, and we'll have r sub 2 plus r sub 1 in parentheses divided by 2, still times in parentheses r sub 2 minus r sub 1 times h. Now we'll go back to our initial redefinition with the r asterisk and delta r to rewrite the volume for the cylindrical shell formula. That is, we would write v equals 2 pi, and where the r sub 2 plus r sub 1 divided by 2 was, we'll replace it with r asterisk. Where we had the difference r sub 2 minus r sub 1, we'll replace it with delta r times h. And this brings us to the volume by shell method formula. The volume obtained by rotating the region between y equals f of x and the x-axis on the closed interval from a to b around the y-axis is v equals the integral from a to b of 2 pi x f of x dx.